Okay, welcome back, folks. We're going to do a little bit of a review of the two different things we covered today. One is a review of some stuff from before, so hopefully it won't be too new. So we got a situation here. Let me kind of actually zoom in a little bit, make it bigger. So what we have is we have a probability distribution here, and what this is the number of billionaires in a randomly selected state based on the current records. How many billionaires are there? So what this tells me is the probability of finding no billionaires in a state is about 10%, 1 billionaire in a state is about 24%, and so on. So again, remember, this is a valid probability distribution because all of these are between 0 and 1, and you can trust me, they all add up to 1, exactly 1. So what's really nice is we didn't have to go and figure out the mean and standard deviation of this. It was given. It said that the average number of billionaires in a state is 12.68, and the standard deviation is 29.02. So what this says is, if I were to actually look at the distribution of them, what would happen is I would have an average of a mean of 12.68 and a standard deviation of 29.02. So if you really think about it, if I were going to draw myself a number line, if I were to draw myself a number line, what I'm going to do is I am going to put the 12.68 in the middle. And then what I need to do is I need to subtract that standard deviation of 29.02. And I hope you can see just from looking at it, what's going to happen when I do that 12.68 minus 29.02. What's going to happen is I'm going to get negative 16.34. So to go one standard deviation down is actually going to put me in the negatives, which is impossible because you can't have a negative number of billionaires. Realistically, what that is saying is that I got 0 here. That's kind of my end. And what's going to happen is I'm going to go ahead and add the 29.02. So we do 12.68 plus 29.02, and that's going to give me 41.7. If I add again, 29.02, it's going to give me 70.72. And if I add one more time, plus 49.02, plus 29.02, I'm going to get 99.74. Now, we can actually kind of take a look and see how often it's between, because this is the mean. So this is in here, the average of all of them. So the deal is, what percent of these people are going to be between 0 and 12.68? Well, if you think about it, it's pretty much all of these people. So 10, 34, 40, 46, 50, 58, 62, 66, 72, 80, 82, 84. So it's like 84% of the people are like 12. So really what's going to happen is we get this huge thing that's going to be like this, and then we're going to get a gigantic tail going out that way. Because if you think about it, like really what we just figured out is that roughly 84% of the people are like in here. So that tells me 16% out. So what's going to happen is the shape of X is going to be clearly skewed to the right. This is clearly skewed to the right because that 0 is kind of my floor and everything kind of gets mashed in there. So it gets really tall. And in this case, what would the shape of Y be? Because the shape of Y would be getting $1 million from each billionaire. All I'm doing is multiplying. And if I'm going to multiply this times 1 million, all it's going to do is it's really just going to keep that same shape. It's still going to be skewed right. The reason it's going to be skewed right is because even though this 12.68 is going to be multiplied times 1 million, what ends up happening is that standard deviation is also multiplied by 1 million, because what ends up happening is we can multiply constants times means and standard deviation. So I'm going to go back and share that screen again so I can kind of show you. So again, what I have here is I have about 84% of my data is falling between 0 and 12. What I did is I went through and I added up all of these probabilities. When I added up all those probabilities, again, 34, 40, 46, 50, 58, 62, 66, 72, 80, 82, 84. I mean, 84% of my stuff is between 0 and 12. So that really says that the majority of it's here, so we got it skewed right. To find the mean of Y, the mean of Y is 1 million times the mean of X. So in this case, it's 1 million times 12.68. So again, they would expect to receive $12,680,000 on average. Calculate and interpret the standard deviation. Well, the standard deviation of Y, since again it's a multiplication, we're allowed to multiply. We're going to go ahead and multiply that. So we're going to do 1,000,003 times 29.02. So this is going to give me $29,020,000. So what this says is the amount of money received by a randomly selected state. Typically varies by 29.02 million on average from the mean of 12.68 million. Okay, so again, that's our calculate and interpret standard deviation. And then it says each state agrees to invest $500,000 to improve roads. Therefore, the net amount of that money selected after the billionaire tax is Y minus 500,000. Well, okay, so the thing you're going to have to do now is we're going to find this new mean N, which is our mean of what we collected minus 500,000. We can subtract, so we can just go ahead and say it's going to be 12,680,000 minus 500,000. So this is going to equal $12,180,000 because we can subtract. But when it comes to standard deviation, we don't add or subtract a constant because we're taking it out on average from all of them. So what's going to happen is it's going to stay the same as $29,020,000. It's not going to change. So again, the rules are, if you remember, just as a reminder, the rules are as follows. If we're going to add or subtract, if we're adding or subtracting a constant, we do that to mean, we do that to standard deviation. Or no, sorry, we don't do that to standard deviation. We leave standard deviation alone. If we multiply or we divide by a constant, we do it to mean, we do it to standard deviation. So that's a little bit of a review. So that's the first piece that we talked about, a little bit of a review from before. So hopefully that helped.